Okay, so in solving our multi-step inequalities, use the same rules as solving multi-step equations, but there's a but. But remember, what did we learn back in 2014? When you're solving inequalities, there's a time you have to reverse the inequality symbol in this process of solving. What is that time that you have to reverse the symbol, the inequality symbol, when you're solving it? Cameron?
Multiplying or dividing by a negative.
Yeah, let's fill that in. Let's remind ourselves that if we multiply or divide, doesn't matter, either of those operations, if you multiply or divide by a negative number, that's when we are going to have to remember, oh, we have to reverse the inequality symbol. We can't forget that little thing. So we're going to use the same rules as solving multi-step equations. Undo addition or subtraction first, then undo multiplication or division. Well, when we're undoing that multiplication or division, if we multiply or divide by a negative number, we have to make sure we remember to reverse the symbol. Okay, so let's just go right to work practicing because we really have all the skills for this. What are we going to do first in number 1? Class, together, what are we going to do? Subtract 6. 6 is being added to the 3 x's, so we're going to subtract it. So now our inequality statement reads 3x is less than or equal to, it's a negative 12. It's kind of like our temperature outside right now. It's 12 below 0, and it drops another 6 degrees. Where's this going to end up?
18.
Negative 18. Okay. And then what would be our next step in solving this?
Divide by 3.
Divide by both sides by 3. So 3x has to be divided by 3. Negative 18 has to be divided by 3. Did we divide by a negative?
No.
We did not divide by a negative. We're going to divide into a negative, but that doesn't matter. We're not dividing by a negative. So we can say x, and we leave the symbol going the direction that it is. And what's negative 18 divided by negative 6? Negative 6. So there's our solution. And we even like it in that order because the variable's on the left side. Okay, well, let's also remind ourselves. We've now gotten the algebraic solution. We're saying x can be any number less than negative 6 or negative 6 itself, right? Okay, so now we need to show that on a graph. So remember when we graph, we show the number that is kind of like our starting point, and then the integer neighbors. Who's the integer? What number is the integer neighbor to the left?
Negative. Like negative 5.
To the left.
7.
Negative 7. And about equal distance away on the other side, the integer neighbor to the right is?
Negative 5.
Negative 5. Okay. So what kind of a circle are we going to put at negative 6? A closed one, a shaded in one. Why do we shade it in?
Because it's included.
Yeah, it's the equal to part. It's included. So negative 6 is a solution, so it has to be in the shaded region. So we shade the point. And then what numbers are less than negative 6? Is negative 5 less than negative 6, or is negative 7?
Negative 7.
Negative 7, so we have to shade to the left, don't we? Okay. There are lots of other numbers besides negative 7 that's less than negative 6, but we were just kind of checking out the integer neighbors. Okay. Any questions? So, are you learning anything really new today?
No.
No. You're taking all of the skills that you've learned previously and just pulling them all together now to solve multi-step inequalities. Okay, any questions about number 1 at all? Okay, let's move on to the second one. Take a look at it. What do you want to do? Subtract 8. Anybody want to agree with JC? We're going to subtract 8? Yeah, okay, we get a second. All in favor signify by saying aye. Aye, okay, let's subtract 8 from both sides. After we subtract 8, What does our inequality statement read now?
21 is greater than -3y.
Okay, 21 is greater than -3y. When you're undoing the addition or subtraction, that's not the step you have to worry about whether you should reverse it or not. It's the next step when we're undoing the multiplying or dividing. So what should we do to both sides now? Divide by -3. So 21 gets divided by -3. -3y gets divided by -3. What's a negative divided by, or what's a positive divided by a negative? A negative, and what's 21 divided by 3?
-7.
7, so we end up with a -7. Did we divide by a negative?
Yes.
So what do we have to do?
Switch the sign.
Switch the sign from is greater than to is less than. And the -3's cancel each other out, and we have y. Okay, we have two options here. We can leave our algebraic inequality solution like it is and just go right to graphing it. Or we can say, I don't like the variable on the right side because it messes me up when I'm graphing, and first rename this inequality statement before we graph. Okay, so I'm going to do the renaming for those of us who especially need to do that. So this is a solution, or we could say it is also known as, we want the y and the -7 to trade places. Well, if the y and the -7 trade places, what has to happen?
The symbol has to switch.
The symbol has to switch again. And that's okay that it switches again. Now we're switching it for a different reason. We're switching it because we want the variable on the left side instead of the right side. So we say, y, you trade places with -7, and the symbol is going to become is greater than. And why is it kind of convenient to have the variable on the left side? Can anybody explain to us why it's convenient? I need to add, call on you with a hand so that I don't have to listen to a bunch of mumbling. Okay, go ahead, Cameron. Why is it convenient to change it to y is greater than -7?
Because with the variable on the left side, that arrow points to the direction on the graph.
Yeah, now the direction the arrow is pointing, that's the direction that the shading should go, shouldn't it? It should match up with that. So we're thinking that we probably should be shading to the right of -7. So let's go ahead and put our graph together. Integer neighbor to the left, closest integer neighbor to the left, -8. Closest integer neighbor to the right, -6. Open or close circle at -7? Open. Why is it open? It's not included. Yeah, there's no equal to bar. It's not part of the solution set. And then we need the numbers that are greater than -7. And which ones are those? -6 and all those guys over there are the ones to the right. Like Cameron said, now when we have the variable on the left, the inequality symbol points the direction you should really actually shade. Okay? So questions about that one at all? So we actually reverse the inequality symbol twice, but for different reasons. So we have to keep it straight. When do we reverse it, and why are we reversing it? Okay? And it's okay if it only happens one time, and it's okay if it has to happen 2 times, because there's 2 different reasons for reversing the inequality symbol. 1, you multiply or divide by a negative number. 2, you want the variable on the left side instead of the right side. Okay, we got one more to practice, and then I'm going to let you go to work on homework. -1/2 x take away 4. What's that symbol say?
Less than
Is less than or equal to -8.
add 4.
Add 4 to both sides, okay? Add 4 to both sides of this inequality because 4 is being subtracted from the -1/2 x. And now we can say -1/2 x is less than or equal to 8 below, the temperature goes up 4 degrees. Where's it now?
-4.
-4. Okay, what would be our next move? Rose?
Multiply by the reciprocal.
Absolutely, multiply by the reciprocal of what? Negative half, negative 1/2. What is the reciprocal of negative 1/2?
2 over.
Negative 2 over 1. So we're going to take both sides times negative 2 over 1. What happens when you take negative 2 over 1 times negative 1/2, Dakota? What happens when you take negative 2 over 1?
Just cross itself out.
They cancel each other out because multiplying reciprocal times the number that it is the reciprocal of makes it become 1, and 1x is the same as x. So we have x. What should we do? Should we leave that symbol the direction it is, or should we reverse it?
Reverse it.
Why should we reverse it?
Because you, divide
We didn't really end up dividing, instead we
by multiply.
multiplied, but we multiplied by a negative, didn't we? So we need to flip it over and say now you're going to become is greater than or equal to. I can put that negative 4 over 1. What's negative 2 over 1 times negative 4 over 1? 8. Negative times a negative is a positive. 2 times 4 is 8. And that 1 times 1 downstairs is 1. And what's 8 divided by 1? 8. Okay. So, do we like our inequality statement the way it is right now, or should we change it?
Like it.
We like it because the variable is on the left. Okay. So, let's go ahead and get this graphed. And should we shade the circle in at 8? Is 8 part of the solution set? Yes, it is. Okay. What other numbers are part of the solution set? All the ones to the right. Yeah, 9 and 10 and all kinds of other numbers over there. Okay. Is that the only one on the back side to do? Don't have any others? Okay. Any questions at all?